So this is another question we'll be solving. Two charges separated by a distance of 200 centimeter have equal sign. Now let's take note of this. Have equal sign meaning that the force between them is a repulsive force because they have equal signs. If the magnitude of each charge is 2 microcoulombs, calculate the electric force. So we are told that the distance between them r is 200 centimeter, and we have to convert this to meter. That means we have to divide it by 100 to convert it to meter. So this gives us 2 meter. Okay, so if the magnitude of each charge is 2 microcoulombs, that meaning that q1 is equal to q2 is equal to 2 microcoulombs. It said if the magnitude of each charge is 2 microcoulombs, which is equivalent to 2 times 10 to the power of minus 6 coulombs. Now, calculate the electric force. That means we are looking for the electric force. Now, according to Coulomb's law, we have that F is equal to KQ1 Q2 over R squared. So, now, this is going to become that our F will be equal to 9 times 10 to the power of 9 times our q1 is 2 times 10 to the power of minus 6. Our q2 is also 2 times 10 to the power of minus 6 over the distance. That's 2 meter, which is going to give us 2 squared. Okay, so now using our calculator, we're going to have this to be 9 times 10 to the power of minus 3 Newton, which can also be written as 9 millinewtons. Okay, or this can also be written as 0.009 newtons. Okay, any of this is an answer. So the electric force between the two charges, or of each charge, the charges, is actually 0.009 newton, or 9 millinewton, or 9 times 10 to the power of minus 3, because 10 to the power of minus 3 is milli, which is a submultiple. Okay, so this is the next example we're about to solve. 2-point charges q1 is equal to plus 25 nanocoulombs and q2 is equal to minus 75 nanocoulombs are separated by a distance r is equal to 3 centimeter. What is the force of q1 on q2? Now we are given that q1 is equal to plus 25 nanocoulombs, which is equal to 25 times 10 to the power of minus 9 coulombs. Because nano is a submultiple, which has a value of 10 to the power of minus 9. Okay, now q2 we are given as plus 75 nanocoulombs, which is equal to minus 75 times 10 to the power of minus 9 coulombs. Now, before we go further to solve this question, of course, seeing that this has a positive charge and this has a negative charge, it shows that the force between these two charges is a force of attraction. Okay, so now the distance is given to us as 3 centimeter. Now, of course, we can convert this to meter because we are working with meter according to our SI in the standard units. Okay, so this becomes 3 over 100. This gives us 0.03 meter. Okay, so now what is the force of q1 on q2? So we are looking for the force of q1 on q2. Now, according to Coulomb's law, we have F is equal to kq1 q2 over r squared. Okay, so now that becomes F is going to be equal to 9 times 10 to the power of 9 times q1. Now q1 is 25 times 10 to the power of minus 9 times, now the negative sign here in this charge q2 is not going to be relevant, so it's just going to be times 75 times 10 to the power of minus 9 over r squared. That's 0.03 squared. So F is going to be equal to, now using our calculator to get this value, we have it that 9 times 10 to the power of 9 times 25 times 10 to the power of minus 9 times 75 times 10 to the power of minus 9 over 0.03 squared. Okay, so that gives us 0.03 0.1875 Newton. Now this is approximately 0.019 Newton to 3 decimal place. Okay, so this will be the force of Q1 and Q2, 0.019 Newton. Now that will be all for today. See you in the next video.